Humans communicate in a messy, analog medium. Our languages are filled with layered context and shifting intent. But a computer processor operates on an entirely different logic, managing everything as rigid electrical pathways and binary sequences. For early machines, this was a hard limit. Because computers only process numbers, a paragraph of raw text is mechanically indistinguishable from noise. They lacked the internal logic to parse syntax or recognize the meaning behind a string of characters. Natural language processing, or NLP, provides the conversion layer. It maps human words onto a coordinate system, turning vocabulary into quantifiable data that a machine can actually calculate. To understand how modern AI operates, we have to look at how this data is handled. Most NLP development relies on three distinct structural buckets, separated by the specific data that goes in and the information that comes out. Categorizing AI by these input-output tasks reveals the system as a predictable series of engineering choices rather than a singular thinking machine. The first bucket is classification. In this setup, the model reads an input text and processes it to produce a single outcome or label. This is the logic behind sentiment analysis. A model scans a movie review on a site like IMDb and determines if that specific block of text is positive or negative. Grading these models is difficult if the data is skewed. If 99% of the reviews in a set are positive, a model that simply guesses positive every time will reach a 99% accuracy score without actually reading a single word. To find the true performance, engineers use precision and recall. Precision tracks how many of the model's positive guesses were actually correct, while recall measures how many of the actual positive labels in the entire dataset the model was able to identify. These critical mathematical filters allow developers to verify a model's performance and isolate statistical biases before the system is deployed. The second bucket, multi-classification, increases the complexity. Instead of assigning a single label to a block of text, the system must predict multiple distinct tags simultaneously from one input. This is the basis for named entity recognition, or NER. The model scans a sentence like, "A cute teddy bear is reading," and identifies specific grammatical categories, identifying which tokens represent objects, names, or locations at the same time. The model treats each word, or token, as an individual data point. It applies these labels point by point without losing track of the original sentence structure. In this bucket, the AI transitions from making a broad judgment to performing a comprehensive structural breakdown of the information. The final bucket is generation. This is the most complex task because the input results in a variable, open-ended sequence of new text. This is the architecture used by ChatGPT. Because the response length isn't fixed, the model generates anything from a single word to a 10-page essay. Other major platforms, such as Google's Gemini, utilize this same variable length generation to handle conversational prompts. The system builds these sentences iteratively, predicting one token at a time. This loop continues until the AI generates an end-of-sequence token, a specific mathematical flag that forces the process to stop. Grading these outputs is uniquely difficult. It requires either comparing the response to expensive human references or measuring perplexity, a critical metric that tracks the model's own statistical uncertainty about the specific tokens it just produced. Generation is the most flexible NLP capability, but the lack of a predetermined length makes it the most mathematically difficult to control. The fluid nature of these responses often suggests that the system is consciously thinking through a human input. In reality, the conversational interface sits on top of a strictly statistical mapping. The system calculates the most probable relationship between the input data and the predicted output. This mapping scales from basic tasks, like routing an email into a folder, to the creative generation of original poetry. Every word in our vocabulary is converted into a structured system of mathematical coordinates that a computer can track and manipulate. Breaking AI down into these three structural buckets reveals the progression from simple logic to complex generation as an elegant application of math.